Here we have to solve all positive integer pairs x and y such that 1 factorial plus 2 factorial plus 3 factorial all the way to plus x factorial is equal to y squared. At this point, we should know that the best way to tackle these types of problems are just to plug in some values and see if we can get any information from that. So as of now, let's just test out some sums on this left-hand side. 1 factorial is just 1. 1 factorial plus 2 factorial is 3. 1 factorial plus 2 factorial plus 3 factorial is 9. And then all of that plus 4 factorial, that's 33. And then all of that plus 5 factorial, that's, 153. And at this point, we can realize that we can add more and more factorials along the way, but this unit digit will never change. Because from 5 factorial and onwards, you're going to always have a unit digit of 0. 5 factorial is 120. 6 factorial is 720. And you can go on to 7 factorial, 80 factorial, 1000 factorial. It doesn't matter. After 4 factorial, the units digit of a positive integer will always be 0. So that means that these factorials don't really matter when it comes to finding the unit digit of these sums. So let's look at the sum over here. Well, at this point, from 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, you're going to have a unit digit of 3. However, that's a problem because there is no positive integer, y, that 1 squared has a unit digit of 3. And you can test that out. 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25, 6 squared is equal to 36, 7 squared is equal to 49, 8 squared is equal to 64, and 9 squared is equal to 81. None of these will have a unit digit of 3. And you can go on and test out any higher positive integers, but they will never have any unit digit of 3. So that means that x has to be less than 4, meaning that x can only be 1, 2, and 3 now. So we've significantly cut the number of solutions we can test out now. So let's just test out each solution. If x equals 1, then that's just 1 factorial. And what value squared is equal to 1? Well, that's just 1. 1 factorial equals 1 squared. So therefore, one solution is 1, 1. Let's check out x equals 2. That means that it's 1 factorial plus 2 factorial. Or 1 plus 2, so 3. So does 3 equal any positive integer squared? No. There's no positive integer 1 squared is equal to 3. In fact, the only solution for this is plus or minus the square root of 3. But remember, we're only subjected to positive integers, not irrational numbers. So therefore, there's no value of 2 that would work. X equals 2 that would work. Though, let's just try our final case, x equals 3. So that's 1 factorial plus 2 factorial plus 3 factorial, which is 1 plus 2 plus 6, or 9. Is there any value of y, any positive integer value, 1 squared, equal to 9? Yes, that would be y equals 3. So our final solution is 3, 3. And these are the two solutions to this equation, the only two solutions. Which just goes to show you that when you come across these rather difficult-looking equations, the best way to go is to just plug in some values and see if you can get any information from those values.